Alright, in this video here we're going to talk about how to graph the sine and cosine functions when they have variable amplitude. Alright, so if you haven't watched the other video that I did, or a couple of videos actually, about graphing the transformations of sine and cosine functions, it's important to understand at least one concept out of that, which is the amplitude of the function. Right? In those videos when we talked about the amplitude of the function, it was the number that was in front of the sine or cosine function, a number multiplying that function changes the amplitude of the function, and the amplitude refers to the height of the wave, right? Remember, the graphs of the sine and cosine functions are wave functions, right? They look very similar. They have different starting points, but they have that same shape to them. And the normal amplitude of a sine or cosine function is 1, right? It goes from the x-axis, from y equals 0, up to y equals positive 1, and then it also goes down to y equals negative 1. And it just keeps bouncing back and forth between positive 1 and negative 1. We say that the amplitude then is 1. Right? And if we had a number in front of the sine or cosine, so if it was like 3 times sine x, well then instead of going between positive 1 and negative 1, that amplitude of 3, the 3 multiplying the sine, is going to make it go up to positive 3 and down to negative 3. So it's going to be a taller wave with a higher amplitude, going up and down now between positive and negative 3, instead of the normal sine function, which is positive and negative 1. Okay? So understanding what the amplitude is important to understand what we're going to talk about here. Right, so that's when the amplitude is a constant, right? Just a number, right? When you have that number multiplying the sine function, it just stretches the graph out and makes the waves taller, right? Whether it's sine or cosine, it applies to both of those, right? Well, variable amplitude is when that amplitude, that thing that's multiplying the sine or cosine function, is not a constant, not just a number, but it involves a variable, right? So here, one of my functions, f of x equals a of x times sine kx. Or for cosine, f of x equals a of x times cosine of x, right? For just a constant amplitude, we had just the letter a multiplying the sine or cosine function, right? That was when the amplitude was like 3 or 5 or something like that. But if I have a of x, now it's not just a constant number there. Now it's a function of x, right? So I have, not just 3 times sine of x, but I might have 3x to the 5th power times sine of x, right? Some function of x, something that involves the variable, in that place where the amplitude normally goes, right? So if that's the case, just like when that number was a 3 in front, we said the graph goes up and down between positive 3 and negative 3. Well, if it's a function of x, if it's a of x, the graph of the function lies between the positive and negative of that function. So it lies between y equals negative a of x and y equals positive a of x. Right? So rather than having like 2 horizontal lines that the graph bounces up and down in between, it's going to be 2 curves, 2 functions, and the graph's going to bounce up and down between the graphs of those 2 functions. Right? And we call that variable amplitude because the amplitude of the function is going to vary depending on where you are along the graph. Right, so an example of that, and I'm going to do a couple examples in this video just to kind of show you what this looks like. We have y equals x squared times cosine of 6 pi x. All right, so the x squared here, right? Normally, whatever multiplies in front of the sine or cosine function gives us the amplitude. Here, it's not a number; it's a function, x squared. Right. So what I'm going to do here, and I already typed this stuff in the calculator, so you don't have to waste your time watching me type stuff in. Right, so I'd graph y equals x squared and y equals negative x squared. Right, so whatever that function is that's multiplying my sine or cosine function, right, that's what this is saying up here. The graph is going to go back and forth between y equals negative a of x and y equals positive a of x. Well, in this case, the a of x function is x squared. Right, so I graph the positive x squared and the negative x squared function, and then I graph the whole thing, x squared times cosine of 6 pi x. Right, and I set up my windows in between the x's between negative 1 and negative 1.5 and positive 1.5, and the y's between negative 2 and positive 2, and we can see what the graph of that looks like. Right, so on the bottom here, that parabola along the bottom, that's the graph of negative x squared. Right, the parabola that goes across the top is the graph of x squared, and my cosine function, right, this cosine 6 pi x part of it, is now bouncing up and down. Instead of bouncing up and down between positive 1 and negative 1, it's bouncing up and down between positive x squared and negative x squared. Positive x squared to negative x squared. And then on the other side, doing the same thing. Right, so that's what we call variable amplitude for the sine and cosine functions. Right, so it's still in the shape of a wave, but it's not a wave that has the same height every time. Right, the amplitude, the height of the wave varies because what I have in front multiplying that cosine function is not a constant, it's something that involves a variable, right? It's that function x squared. And so my cosine function bounces up and down between positive x squared and negative x squared. All right, so you can kind of get an idea there for what that looks like. All right, so when you start graphing these sine and cosine functions with variable amplitudes, you can get some really cool looking graphs, right? You get waves where the height changes, and those are used to model real life situations, right? There are some things in life where there are waves that are not always the same height, right? The height gets bigger, the height gets smaller. So these variable amplitude things can model stuff like that. Right, so if you're going into a field where you're going to be, using mathematics to do real life things, you might sometimes have to deal with, these variable amplitude trigonometric functions. And my advice when you have to graph something like this is to use a calculator, a graphing calculator, or to use, like an online graphing tool in order to do that. You can do these by hand, but it's kind of a pain because you have to graph y equals x squared, y equals negative x squared, figure out the period of the cosine graph, and then draw the graph up and down between those. It's doable. It just takes a bit of work, so it's a lot easier to just punch it into the calculator when you have to. Right? But I'm just kind of showing you what this looks like. So I'm actually going to pause the recording and erase this example, and I think I'll put up one more example just so you can see another example of what the graph of a variable amplitude function looks like. All right, the next example we're going to look at here, we have f of x equals cosine of 2 pi x times cosine of 16 pi x. Right, so now we actually have two cosine functions multiplied together, which is kind of a wild thing to think about. And the graph, when we look at the graph, is going to be pretty crazy too. Now in this case, the a of x, that function in front, is this cosine 2 pi x, multiplying the cosine of 16 pi x. Right, so what I'm going to do here is, and I already typed it in again, I graphed the cosine, positive cosine 2 pi x and negative cosine 2 pi x, right? So that's going to give me, my amplitude on the top and the bottom, and then the graph of cosine 16 pi x is going to bounce back and forth between those two. And you see the third function I wrote is cosine 2 pi x times cosine of 16 pi x, right? And now I'm going to set my window, my x from -1 to +1, my y's from -1.5 to 1.5, and I tested that out before I started recording this just so I could get a good window. But when you're doing one of these, like to figure out what the window is, you just try something and see if it works. And if you can't see it very well, you might want to shrink the window or make it bigger depending on what you're looking at. So when I hit enter here, I'll show you what happens. What did I just do? I don't know. I just hit the wrong button. Okay. No. All right, let me hit the graph button. All right, so here's the graph of cosine 2 pi x. All right, and now here's the graph of negative cosine 2 pi x, which is the reflection of that first one. So that's going to be my upper and lower boundary. And then here in between comes the graph of the other cosine function bouncing back and forth between its upper and lower limits, which are the positive and negative cosine 2 pi x. Right, so that's what we get for a function like that. Pretty wild looking, right? So we have two cosine curves as the upper and the lower limits, right? Those form almost like those egg-like shapes in there. And then the other cosine curve is bouncing back and forth between the other cosine curve that goes up and down. So you get a pretty cool looking graph when you do some stuff like that, right? So if you have a graphing calculator, if you use an online graphing calculator, you can play around with it. Like you can do sine of x and then just put any function in front. Do 3x to the 5th power times sine of x and see what it looks like, right? You might find some pretty cool graphs when you do things like that. All right, but that's just briefly, variable amplitude for sine and cosine functions. When you have a function in front of the sine or cosine instead of just a number, right? Remember, just a number just has horizontal lines, and the sine or cosine bounces back and forth between those horizontal lines. But when you have a function out there, well, the function is not horizontal. The function is a curve, and so your cosine or sine curve is going to bounce back and forth between whatever this other function out front is. All right, so that's variable amplitudes of sine and cosine graphs.